Okay, then let's get started. All right, so the seminar is mainly intended for people that have used Kupe before, so I'm not going through all the basics. This is really, and as I said before, this is just a few tips and tricks. But the good thing is that Maui will be almost the same as Kupe. We'll hopefully have Maui online in, say, about a month or so. And you'll be able to use that information as well for Maui. So it will be almost the same thing, if not the same thing as Kupe. Okay, a quick overview. So I'll first start with the compiler drivers on the XC50. There's a specialty for these Cray machines. We only have them on the XC50, and I think it's easy to get confused with these things. So I just thought I'll go through that again. Then a few tips for using Slurm. So stuff that's often that can be quite useful for using Slurm, and some optimization tips to get a bit more efficiency out of Kupe. Okay, compiler drivers. So the compiler drivers only exist on the XC50, not on Mahuika, which will be our new capability machine. Our new capacity machine that will come online in a month's time, and they do not exist on the CS500 systems either that are used for pre and post processing on Kupe and on Maui. So that's an XC50 specialty. And these compiler drivers just wrap around the compilers. So they don't compile anything themselves. They're just there to, as the name says, to drive the compiler. The main intention behind that is to simplify your life, especially when it comes to MPI programs. MPI can be really tricky to link correctly. And so it is then highly recommended to use these compiler drivers instead. And they have the benefit that some of the libraries that we have on the system, namely those that are provided by Cray, are automatically handled. I'll show you that in a moment. But unfortunately, that does not extend to the libraries that NeSI and NeVA provide on the system. And that's something where you can get easily tripped up. So that's why I'm going to discuss it a little bit more. But just once again, when you build code on the XC50, please only use the compiler drivers. You can, in principle, use the compilers directly, but you'll be very likely in a lot of trouble when you try to run that, if it compiles at all. So it is best to only use the compiler drivers. So just use FTN for Fortran code, CC in lowercase for C code, and C++ is then the CC uppercase compiler. And under the hood, the driver will talk to the actual compilers that are listed here on the right-hand side. So if you want to choose a compiler, use module swap, as you see here in that blue box at the top. That's how the Cray programming environment works. It's a bunch of modules that you can swap in and swap out. Never use module purge, not a good idea, because that will unload every single module and you will not be able to use the XC50 anymore. So in a sense that code will no longer compile, and you will also get in trouble at runtime. The only thing you can do is then log out and log back in again. So module purge, an absolute no-no on that system. But otherwise, you can basically use these environment modules to put together your programming environment. So choosing the compiler and load libraries. But you also have to keep in mind that even though the compiler drivers abstract a lot of the interface with the compiler, you still have to use compiler-specific flags. Like here in this particular case, the -f bounce check. That's a debugging flag that's specific to the G-Fortran compiler. So the Intel or Cray compilers will not understand that. So if you change your programming environment, then you still have to change these compiler-specific flags as well. Now, so one thing that's easy to get confused with is the linking of libraries. So we have a bunch of libraries that are provided by Cray. You can always recognize them by their name. So they're always called Cray-NetCDF or Cray-HDF5, Cray-libsci, and so on. If you need one of those, it's enough to just load the module. And if you then have a program like my NC program for NetCDF, so if a program that uses NetCDF, you don't have to do anything. You can just compile it. You don't have to worry about pointing the compiler to where the library is, what the library names, what library names you have to include on your linker line, and so on. It's all automatic. So as you see, I didn't have to change anything for including the NetCDF library in my build. However, this only works with the Cray libraries. So if the library is provided by us, and you can recognize those with this rather complex looking version name. So here at the top here, you'll find grip API /1.23.1 and so on. These ones are provided by us using the EasyBuild software management system. And unfortunately, at least at the moment, we don't have a way to make that automatic. So we might be able to find out at some point how to make it automatic and might be able to deliver it that way. But at least for the moment, you have to point the compilers or the compiler driver to the location of these libraries. So in this particular case, it's the grip API library. That's the software that's used for weather forecasting and climate science. And here I still have to basically use the -i flags, the -l flags to point the compiler to the include directory and the library directory, as well as listing the grip API on the linker line. So I have to add my -l grip API. Otherwise, the code will not build successfully. So these environment variables that I used here, EBRoot, that's something that the EasyBuild software management system does automatically. So it defines these environment variables, then adds on the name of the module, so EBRoot grip API or EBRoot ESMF, whatever the library name is, gets appended, and then you can use that environment variable to avoid having to write down the exact place where these libraries are and where these include files are. And if you're unsure which of these EBRoot environment variables are available, just use module show, and then you'll get the full list and just take it from there. One other thing that the compiler driver does, as I mentioned already, it also takes care of MPI. So building an MPI program is as easy as building a serial program. You just compile it. You don't have to do anything. It's a bit different when it comes to OpenMP. So with OpenMP, that's a compiler-specific thing again, and every compiler uses a different way so you have to use a different way to tell the compiler that it should honor the OpenMP directives. And so for GNU, it's -f OpenMP. For Intel, it's -OpenMP. And the Cray compiler does it by default. But there you have to adjust your build settings again. Okay. Does anyone have any questions so far about the compiler drivers? Or shall we go on to using Slurm? Okay. Okay, so Slurm is our scheduler, so the software that you use to get your jobs running on the HPC. Slurm is a very complex beast. We can easily spend an hour or two just talking about Slurm. I won't go through the basics of how to submit a job and so forth. I guess everyone who's worked on the system has done that already. But I just compiled a few useful commands that people have asked for over the last month, and that are hopefully useful to you. So one thing that when you get to the system is you want to know which partitions there are, so which queues there are that you can run your jobs on. That's done with the sinfo command. Most of these Slurm commands have a ---- format option that let you choose additional fields that are not shown by default. So you can run sinfo just as it is, but it won't show you everything. And what it shows is often abbreviated. That's particularly annoying when it comes to these partitions, because when you select a partition to run your job with, you have to precisely replicate the name. So you can't abbreviate it. You can't use lowercase where there's an uppercase character. And if you just run as info, it won't show you the full name. So if you want to see the full name, then you have to use that particular specifier %P. Then the next question, of course, is which of these partitions are available for me personally? So there's a lot of partitions and a lot of accounts on the system. And to find out about that, use the next command as account manager and then show user. You can then type in your own username or use the environment variable $user. And then with a sock. And that gives you a long list of, hopefully long list, or maybe a very short list of accounts and partitions that you're eligible for. Another question is the HPC busy? Do I have a chance to run anything anytime soon? If you want to know that, there's a couple of commands that you can use. The first one is show nodes that gives you a summary. So show nodes with -- uppercase format equals CPU state. That gives you a summary that tells you how many CPUs are allocated, meaning that they are used by some job, how many are idle, so that means that they can be allocated for your job. Other are probably all sorts of failure states and so forth, not really of much interest here. And then total is the total amount of CPUs, and by CPUs I actually mean core that are in the system. If you want to know a bit more, there's a second command here that has a bit more information that also lists the node name and the amount of memory that's available on each node. Because it doesn't really help you if you know that there are a few CPUs that are idle, but if all the nodes are allocated, you still can't run. If the system is almost out of memory, you wouldn't be able to run either. So that's why it's sometimes useful to have a bit more information. And of course, it doesn't change anything. If you might still not be able to run because the cluster is busy, but at least you can find out a bit more about what's going on in the system. And then of course, it brings us to the next question: why does my job not run? The command for that, you've come across it already, is sq. You can limit the output to your own user with -u, and then with that -- format specifier, I selected the few fields that are of interest here. The most important job states are either run, so it's running already, or so with an R, or PD for pending. There are more job states. You'll find that on the man page for SQ. And for the pending ones, the Slurm also gives you a reason why it is pending. I picked out two that are quite common. One is called association group CPU limit. That means that there's more than one job running, there are jobs running for a particular account that have already reached the maximum limit of cores that are available for that account. So every account has limits, and it's either because if you're the only user in that account, you're using the maximum for that account already, or if there's several people, then there's someone else using up all the cores that are available. Another one is the QoS group node limit. So that's the quality of service group node limit. Quality of service is roughly a priority level. So normally everything has standard priority, but we have some jobs that get higher priority, like the weather forecasting. That runs at a different QoS level. And for each QoS level, there's a certain node limit, how many nodes in the system each level can use. And if you see that, that means that basically for the quality of service levels, so say the normal level, all the available nodes have been used up. But same here, there are more reasons why a job hangs in the queue. There could be something misconfigured, for example. So for that, you would have to consult the man page to get a full overview of all the different reasons. Next one is how much memory did my job use? For that, you have to consult the saccount command, so SACCT, and that gives you an overview over the jobs that you've run recently. I'm not sure how long back it goes. It's probably the last day or the last couple of days or something like that. It gives you the job ID, the name of the job in this particular configuration that I show here. And max RSS means that's the maximum amount of memory used by one MPI rank. Or if you only have a serial job, then that's the one. If you have an MPI job, then across all the MPI ranks that you ran, that gives you the maximum amount of memory used by one of those. And that's very useful if you want to specify the memory consumption of your job and you don't necessarily know that beforehand before you've run it. But Slurm gives you the ability to specify memory consumption, and that would be the way to go. So you run your job, measure how much it took, and then specify it. And that's very good because the CS500 nodes will be shared, or they are shared, and there it's very important that you specify how much memory you use. And on MAUI, we'll have nodes with different amounts of RAM. And to make sure that you get onto the right system, if you use a lot of RAM, for example, then you have to specify how much you need so that Slurm can decide where your job should go. Okay, and the last thing I want to discuss in the context of Slurm is the job runtime environments. That's also something that can easily be a bit confusing. So when you submit a job to Slurm, you start here on the left in your submitting node, so on login.kupe.niva.co.nz, and you have your session with the use environment. So that by use environment, I mean you have a set of environment variables that you set up. Now you use sbatch with a job script to get your job started. And sbatch will put your job script on the HPC, and the job script will run in its own environment. So you can also define environment variables there and so on. And then at some point in your job script, you'll have srun, which will then put your job, which will then launch the actual executable, so a simulation or whatever you do, and possibly put that onto several nodes. And the application itself will once again run in its own environment. So by default, Slurm exports these environments in both steps. So the sbatch will by default export all the environment variables that you've defined in the use environment into your job script environment. So you can access variables from your use environment in your job script environment. And srun will do the same. So if your application looks for particular environment variables, they will also be handed through by srun automatically. That's a good thing, of course, if you don't want to specify everything in the job script, but it also has disadvantages. The biggest disadvantage is when you try to submit a job from a CS500 node to the XC50 or from the XC50 to the CS500. And the reason is that there's one variable which is called LD library path, which is used to find shared libraries. So some of these shared libraries are on the global file system that's visible from every single computing node across the whole system, so both CS500 and XC50. The problem, however, is that the CS500 uses a different operating system than the XC50. So we have CentOS on CS500 and SLES on XC50. And if you export a library path, it's very likely that an application on one system will try to run with the shared library that was built for the other system. And so we had such cases, and you get very, very obscure error messages. So all of a sudden, Bash is crashing. Bash never crashes, right? So you get really bizarre things happening. And the reason for that is the automatic export of these environment variables. So in these cases, you really have to give it some thought. You can prevent that export by using the -- export equals none option. So both in sbatch and in srun separately, there are two steps involved, right? Two different steps, sbatch and srun. And by doing that, you also guarantee that you always start with a clean slate when your job script runs. So you will get no interference. That's another thing that can happen, that your use environment interferes with your job script environment or your application, and you can prevent that basically by not exporting anything. But that means that you have to really set up the entire environment again in your job script. Okay, any questions for Slurm? Or did I confuse you already too much? Okay, all right. So the last thing I want to talk about are a few simple optimizations. So that's basically intended as some lightweight things you can do to get the most out of the system, just to save a few core hours and get your jobs running quickly and efficiently. So the first recommendation I want to make is we have 3 compilers on the system. So we have the Intel, Cray, and GNU compilers, and it's always worth trying out all of them for your codes. So hopefully your code will compile with all of them. Unfortunately, that's not always the case, but in most cases, it will hopefully happen. And then you can measure runtimes. And we've gathered a lot of experience, my colleagues and I, with the different compilers over the last month, and each one of them has its strengths and weaknesses. So there's no way to say that that one compiler is better than the other. It will be different for every code. And it also has the benefit that 3 compilers are looking at your code, and it's more likely that they'll find some problems, some bugs or so that are in these codes. So it's always a good idea to try different compilers. And I know it's annoying when something seems to work perfectly with one compiler, but then crashes miserably with another. But it's an opportunity, so it's really not meant to annoy anyone. It's really good if because you can look at the code and you might find actually quite a big problem. Another simple optimization you can do is you can try both the Broadwell and Skylake targets. So the microprocessors that we have on Kupe and on Maui are Skylake. That's the latest generation of the Intel architecture, and Broadwell is one generation before. And one of the big changes with Skylake was the AVX 512 vectorization. So that's the ability to compute many numbers at once. And some of the software will be able to use it, but some of that will not be able to use it very efficiently. And so it turned out after a bit of experimenting that it often gives better performance to build a program for Broadwell, but then still run on the Skylake processors that we have on Kupe. It's a very simple thing to do. You just need to load a different module before you build your code. So instead of Skylake, just load Broadwell. And in some cases, you might get a few % performance benefits. But if you use enough CPU, so if you use enough core hours, it actually makes a difference. And it's a very simple thing to do. Another important one is hyperthreading. So hyperthreading is the ability of our cores on the system to run 2 threads at once, but you don't get you don't get an extra core with hyperthreading. What the processor does, it just flip-flops between 2 threads. When one of them has to wait for memory, for example, and is idling, then it can quickly switch to the other thread and then run that for a bit until that one gets stuck as well. And so it just changes forth and back. And with some codes, it can give you a performance advantage. With some codes, it goes the other way and it will run much slower. So I would always recommend starting without hyperthreading. It's very likely that it will harm your performance. And to do that, just add -- hint equals no multi-thread to your Slurm configuration. And then once you've set up everything, and if you want to give it a try, then just go ahead and remove that again and see if you can get a bit of performance out of hyperthreading. And the last one that I have for today is OpenMP. So for OpenMP, you need to declare to Slurm how many cores you need for each task. So for each process that you run, you do that by setting up CPUs per task, and at the same time you also need to set the environment variable OMP num threads. Where you have to be sure that you set it to the same value. And to do that, the easiest thing to do is just to use the environment variable Slurm CPUs per task that is defined automatically, and that will give you automatically consistent numbers of threads between what you ask Slurm for in terms of resources and what you then use in your program at the end. And if there's a mismatch, you can either have the situation that you waste resources by not using all the cores you asked for, or it goes the other way, that you try to squeeze many threads into one single core, and then it will run really, really, really slow. And it's always good to define it, even if you actually don't use OpenMP yourself, but maybe a library that you linked into your program uses it. So it's always a good idea to safeguard against that, and just that one. So it's just set CPUs per task equals 1, and then you can be sure that you always get it right. Okay, now that's the end of my slides. And we're now in the question and answer session, if you like. So does anyone have any questions so far? Okay, so I just hear that there are questions on the Google Doc. I'll just bring that up. Okay, so then I would quickly go through the list of questions here. So the first question is, any idea when Globus file transfer will be available on Kupe and Mahuika? And it has already been answered. There is no plan to have Globus working on Kupe, but we will install Globus on Mahuika. No date set yet. Yes, so there's work is going on, but as far as I know, it will still be a while. So a question from Johnny regarding S-info show notes. Any idea why so many processes are idle at the moment? Well, I guess there's not enough people running jobs, so that's not the only reason, unless some nodes have been taken out of the queue for one reason, but maybe it's just that the class is not very busy. However, I don't know for sure how it is configured at the moment with respect to the weather forecasting that runs at a higher priority level. So it could be that some nodes are reserved for the forecasting. So that might be another reason why some nodes are not busy at the moment.
Okay, hi, can you hear me?
Yes.
Yeah, so thanks for that. So the reason I was asking that question was that just for example, I have a few jobs at the moment which are only asking for like 2 nodes, for example, but are not running. So I was wondering, because there's more idle nodes than there are active ones, but jobs are not being run. So I was just wondering why that is.
So you can see that if you have a look on the reason why your jobs are not running, and you see it's associated group count. No, I'm not into detail yet what that means, but I guess it's about a group limitation you have, which is already reached with running jobs.
Okay.
Yes, yeah, I agree. I just looked it up myself on the system, and I can just, hang on, I'll just move that window into the screen. I hope you can see that. Can you see the terminal now?
Yep.
And so I guess you're talking about these jobs here. So the upper ones here are running, so they have state R for running, and the lower ones here have PD for pending.
Yep.
And this is one of the cases that I mentioned before. So that's the association group CPU limit. That means that for a particular account that's used here, so that's this one, there are several people running, I guess, and Slurm has, so the amount of cores that are used for that account have reached the limits, so you can't run at the moment. Right. You have to wait until one of the other jobs finishes.
Okay, cool, great, that makes sense, thank you.
Okay, there are 58 nodes idle while only 46 nodes are allocated. This you can also see using S-info, the reason for the actual, okay, right, so that's the answer, yeah, okay. And the last question, can you explain further why the srun command is useful? I normally just sbatch a script that starts executables without srun. And the answer, srun will invoke MPI exec underneath. And it's also possible to pass additional arguments to turn off multithreading, for instance, always use srun. Yes, so I guess that you may not need srun if you have a serial program that you run. That's not something that you would do on the XC50, but you will likely do that on the CS500 or on Mahuika. But if you have an MPI program, so a program that will spawn a large number of MPI ranks, then you will need an MPI runtime environment for that. And srun basically creates that. So srun will create the environment and will then start your program on the number of nodes that you need. So if you need 20 nodes to run your program, it will do that for you. So for that, it's really important to have srun. And you get the additional benefit that you can configure srun specifically, say with the environment export that I mentioned before. If you, for some reason, if you don't want to export the environment from your job script to your application, then you can use srun to prevent that by adding on the -- export equals none flag. Or you can pick and choose, so you can list the number of environment variables that you want. And there are further configurations you can make with srun specifically. Okay, does anyone have any more questions? So now, looking at the time, we are now at 2:30. So that would basically be the end of the webinar. If you still have some questions, then maybe something that you encountered today or tomorrow, so then please feel free to send us an email to support@nesi.org.nz, or add them on to the Google Doc if you like, and we'll answer that for you. And yeah, otherwise, I hope that you enjoyed the webinar. So yeah, feel free to contact us with questions, and have a good afternoon. Thanks for joining in.